Trigonometry is a branch of mathematics concerned with the relationships between angles and side lengths of triangles, in particular the trigonometric functions relating angles and right angle ratios. Sounds like a whole lot of yapping to me, and I'm sure it is to you as well. So I'm going to compress as much of the topic as I can in this video. The entire trigonometry not really explained in 12 minutes. There we go. We begin with a concept which was probably the first one my smooth brain was ever shown, and that is the right angle triangle. It's a right angle because one of its angles is always 90 degrees, and that allows for a particular equation to hold true for any variation of this right angle. A squared plus b squared equals c squared. For practicality, let's square root both sides. Length c is equal to the square root of a squared plus b squared. What this thing means is that if we are given two lengths of a right angle, we can find the missing third length. The longest length is always the diagonal one called the hypotenuse, and if we put an angle at one of the ends of the hypotenuse, the length opposite to the angle is the opposite, and the length adjacent to it is the adjacent. That's crazy. So if we are given the lengths of the opposite and adjacent, 3 and 4, and we wanted to find the hypotenuse c, all we do is chuck this in the calculator, and you get 5. Why is that equal to 5? Well, because the square of 3 is 9, and the square of 4 is 16. 9 plus 16 equals 25, and the square root of 25 is 5. Whoa, hang on a second. If you've done any form of algebra, you should know that the square root of a positive integer is always plus or minus the value. But because we are dealing with geometry, lengths are always positive, so it's not plus or minus 5, it's just 5. If you were given the hypotenuse and one of the other lengths, simply take the original thing that we figured out and put the values that you know in it, whether the hypotenuse is being subtracted by the other thing you know, and then do the same calculations and you get your missing length. SOHCAHTOA. When I first heard SOHCAHTOA, I thought it was the name of a Greek mathematician like Pythagoras. Right, yeah, no. Contrary to unpopular belief, it literally just means this. Sine, opposite hypotenuse, cosine, adjacent hypotenuse, tangent, opposite, adjacent. Clearly, each of those side lengths have to do with the different angle functions. And one of the easiest ways to remember the processes behind using these to work out angles or side length of right angles is by putting them in their own little triangles like these. These are formula triangles. Now, I know they're not necessarily the best way to learn math in the long term, but for simpler concepts like SOHCAHTOA, it's pretty useful. So, if you wanted to find the angle theta, you would first look at what lengths you know. Say you were given the opposite and the hypotenuse, then to find this angle, just take the inverse sign of the opposite divided by the hypotenuse, and you follow the same process for finding the angle with the other legs. And if you wanted to find either the opposite or adjacent, depending on which other length you know, just multiply that other length by your angle. The unit circle. Sine and cosine are waves, and the reason for this is something called the unit circle. It's exactly how it sounds, a circle with units. And these units involve cosine, sine, and radians. What are radians? They're pretty much a type of angle that are related to the radius of a circle. And for the actual definition of the radian, that circle is the unit circle. So the unit circle has a radius of 1. This means that 1 radian forms an arc length from the circumference that is the same as the radius. Therefore, if you increase the length of the arc, the amount of radians increases also. So you could ask, how many radians are in a full 360? Well, keep lengthening the arc length until it is the same as the circumference, and that gives a full 360 degrees worth of radians. The circumference of a circle is defined as 2 pi times r. This means that there are 2 pi amounts of radiuses laid to create the full circumference. And so, dude, 2 pi is the amount of radians in the full 360 degrees of the unit circle. Yeah, okay, pal. But that doesn't explain what sine and cosine have to do with it. Well, the unit circle is broken up into 4 quadrants with increasing radians going anti-clockwise, in which these angles are conveniently broken up into rational fractions of pi. Take 45 degrees in the first quadrant, for example. Now, 45 degrees is actually the same as pi over 4 radians. We know this by multiplying pi over 4 by the conversion quantity 180 over pi, and you get 45. What this means is that if you wanted to convert any degree into radians, divide it by 180 over pi, and if you wanted to do the conversion the other way, just multiply it by 180 over pi. But let's imagine that you wanted to find the coordinates of the ends of an arc length. Now, it's actually pretty simple. As long as you know the radius of the circle and the radians that subtend the arc, let's say the arc goes from 30 degrees to 60 degrees, which is the same as pi over 6 to pi over 3. To find these points here, all we have to do is compute cosine of pi over 6 to find this x coordinate and sine of pi over 6 to find its y, and then do the same for pi over 3. And bam, you have the coordinates. as long as you multiply each one by the circle's radius. Otherwise, that point will literally end up in the back rooms. Interestingly, because of two types of right angles called the 30-60-90 triangle and the 45-45-90 triangle, these key fractions of pi will return fractions of square root 2, square root 3, and 1. I don't want to keep saying radians to denote the angle, so I'm just going to say angle theta instead. Because cos of theta is the x, and sine of theta is the y, and the gradient of a line is defined as the difference in the y between 2 points on the line divided by the difference in the x, this means that we can also find the gradient of this line by simply dividing sine theta by cos theta. I'm going to leave this diagram here for a couple seconds. It's important to notice that the coordinates of the reflected angles are obviously just sine inversions of each other. And because you guys seem to like my beatboxing in the last video, I'm going to do a little more of that while you write this down. Okay, I get it, my beatboxing sucks. But do you know what doesn't suck? Brilliant.org, the sponsor of today's video. My favorite hobby was procrastination, up until I downloaded Brilliant on my phone, which allows me to learn a massive range of content in maths, science, and computer science right from my pocket. They've got bangers like exploring data visually, calculus, geometry, thinking in code, literally the whole shebang. Through these, you learn by doing, building skills in problem solving, analytical thinking, and overall, a daily learning habit that's much better than scrolling Instagram Reels, or even worse yet, Reddit. Oh my god, Reddit. One of the best parts of Brilliant is that the courses have the main content mixed along with relevant practice problems in order to promote active learning. And I know I've said this in previous videos, but Brilliant is 6 times more effective than watching boring lecture videos. So that sounds especially based to try everything Brilliant has to offer for a full free 30 days. Use my link, brilliant.org/findwhy, and you'll also get 20% off an annual premium subscription. Laws.
Run.
The unit circle is great and all, but it's not a triangle, it's a circle. Where do triangles come in? Well, there's actually 2 very important laws to know for geometric problems, and they are the law of sines and the law of cosines. Remember this, use the law of sines if you know 2 angles in one side, or 2 sides in the angle opposite to one of them, and use the law of cosines if you know 2 sides in the angle between them, or the 3 side lengths. Okay, but that doesn't explain what they actually do. If you were given this triangle here, which law should you use to find length x? The answer is cosine law, because we know 2 side lengths in the angle between it. Traditionally, this law takes the form c squared equals a squared plus b squared minus 2ab times cos of capital C, which is the angle, but let's replace these variables with what we have been given. Because x is the length that we want to find, we replace c squared with x squared, a squared with 5 squared, and b squared with 4 squared. Now, because the side length x is the little c in the original equation, the big C is the angle opposite to length c, which is 92 degrees in our problem. For these triangles, we deal with degrees, not radians. Because we want to find x, we can square root both sides, and our final equation for x becomes x equals the square root of 5 squared plus 4 squared minus 2 times 5 times 4 times cos of 92 degrees, which is roughly equal to 8.13. Let's imagine a new triangle where you know 2 lengths a and b and the angle opposite to them, and you wanted to find the angle opposite to b. Well, we're going to have to use a sine rule, which states that sine of capital A, which is the angle, divided by a equals sine of capital B divided by little b, which is effectively saying that the ratio between an angle and an opposing length is equal for all of them within that triangle. Just like we did for the law of cosines, we can substitute in our values that we know and then solve for the angle b, which in our case is x. Sine of 48 over 5 equals sine of x divided by 4.5. Now the solution from here is pretty simple, we just want to isolate x. So multiply both sides by 4.5 to eliminate this division, then apply the arc sine function to both sides, which is the inverse function of sine. Inverse functions simply eliminate the effects of the function, denoted as the function to the power of -1. For example, the inverse of f of x equals x, because the inverse of f cancels out the f function. So yeah, sine is cancelled just down to x, and so x equals the arc sine of 4.5 times sine of 48 over 5, which is roughly equal to 41.98 degrees. Trigonometric identities. What is an identity? It is the equation that is always true no matter what values are substituted in. The first one we're going to look at is the Pythagorean identity, but to understand it, let's first go back to the center of the circle is called the origin, and it has the coordinates 0, 0. If we choose a random point on the circumference and draw a line from the origin to that point, it actually forms this right angle where the x coordinate of the point is the length of the base and the y coordinate is the length of the side. Because this is a right angle, we can apply the Pythagorean theorem. X squared plus y squared equals 1 squared, which is 1. Now I'm hoping that you haven't just been playing Fortnite this whole time. You can actually remember from earlier that the x-coordinate for the unit circle is defined as cos theta and y is sine theta. This means that the cos squared theta plus sine squared theta equals 1, and that right there is the Pythagorean identity. And then you have two other Pythagorean identities, one for it divided by sine squared of theta and the other by cos squared of theta. There's also the reciprocal identity, so 1 over sine theta equals cosecant of theta, 1 over cos theta equals secant of theta, and 1 over tan theta equals cotangent of theta, which is also the same as cos theta over sine theta because tan theta equals sine theta over cos theta. There is something else called angle, sum, and difference identities, which are exactly as they sound. If you have sine of two angles added or subtracted from each other, it is equal to the sine of A times cos of B, plus or minus cos of A times sine of B. For cosine, it's practically the same, but instead, it is cosine of A times cosine of B, and then the minus plus sign, which is like the dependent version of plus or minus. So, if it's cos of A plus B, then it's that minus that, but if it's cos of A minus B, it's that plus that. Now, even more confusing yet, tangent of A plus or minus B equals tangent of A plus or minus B. Okay, that's pretty sure. But then it's divided by 1 minus plus of tan of A times tan of B. Alrighty, now we have double angle identity. So if you had the sine of double angle theta, so sine of 2 times theta, that'd be equal to 2 times sine theta times cos theta. Because you have cos of 2 times theta equals cos squared of theta minus sine squared of theta. And finally, tangent of 2 times theta equals 2 times tangent divided by 1 minus tan squared of theta. Oh. Well, we've covered quite a few things in trigonometry, and I know it's not actually everything in trigonometry. There's always parametric equations. There's tons of stuff to cover, but this will give you a decent framework to work from to move on to more high-level content. So we've covered the Pythagorean Theorem, SOHCAHTOA, the unit circle, laws of triangles, trigonometric identities, and of course brilliant.org, which you should check out using my link in the description. I hope you guys enjoyed. Good luck with your trigonometry, and I'll catch you in the next one. Bye. This is terrible. It's terrible. It's bad. It's not even good. Why do people watch this? Yeah, okay.
How much gas do we have?
Like, none. 0. We're out.
Oh, don't make me do it. Don't make me do it.
Oh,